At the beginning of the 8th century, the world into which Jabir ibn Hayyan was born was turbulent, yet astonishingly rich with a thirst for knowledge. The map of the Islamic Caliphate then extended from Andalusia in the west to the Indus region in the east. In the hands of the caliphs lay not only military power, but also a vast repository of knowledge and culture from across multiple civilizations. About half a century before Jabir's birth, in 750 CE, the Umayyad Caliphate fell, and the Abbasids rose to power. Under the Abbasids, Baghdad soon became one of the greatest cities in the world. With royal patronage, a new chapter of intellectual pursuit began, a period that would be remembered in history as the Golden Age of Islam. To understand the context of this era, we must imagine the vibrant heart of Baghdad, the future Beit al-Hikmah, or House of Wisdom. On every street corner, books were sold, Greek philosophical texts were being translated with enthusiasm, and ancient Persian scientific traditions were blending into the Islamic civilization. Medicine, mathematics, astronomy, philosophy, each field experienced a massive translation movement, where knowledge ranging from the Indian concept of zero to Greek medical treatises was rendered into Arabic. This treasure trove of knowledge was not merely preserved. It was actively scrutinized, refined, and developed. Yet alongside this intellectual flourishing existed political instability and ideological conflict. The Abbasids ruthlessly suppressed rivals to consolidate their rule. Shia-Sunni tensions, power struggles among various communities, and regional revolts were intense. Remarkably, despite these turbulences, the pursuit of knowledge never ceased. Often, rulers supported science and philosophy to legitimize their authority. Caliphs like Harun al-Rashid and his son al-Ma'mun spent enormous resources on knowledge and learning. Jabir ibn Hayyan was born into this environment. One can imagine, during his childhood, walking through the streets of Kufa or Basra, where students from various lands gathered, some explaining Greek medical treatises, others debating Indian astronomical formulas. Shops sold fresh paper, pens, and translated books. Before his eyes, a new world was emerging where knowledge was not limited to religious instruction, but was a tool to understand nature, experiment with metals, prepare medicines, and improve human life. At that time, alchemy, or chemia, was highly popular across the Arab and Persian regions. Many believed that base metals could be turned into gold, or that an elixir of immortality could be created. Though largely mystical thinking, these practices laid the groundwork for experimental chemistry. When Jabir was born, the excitement of alchemy was spreading everywhere. Alchemists created various instruments in their laboratories, experimented with herbs, and secretly recorded their formulas. This imaginative yet inquisitive environment would later shape Jabir's scientific mindset. Thus, the historical context of Jabir ibn Hayyan's birth was a multidimensional era. Political instability coexisted with a cultural renaissance, and despite religious differences, scientific curiosity flourished. The Islamic Caliphate's diverse environment placed him in a society where he inherited knowledge from Greek, Indian, and Persian civilizations while also engaging with contemporary Muslim thinkers. It was in this context that he would one day become a pioneering figure in laboratory-based science. Jabir ibn Hayyan, known in the Western world as Geber, led a life shrouded in curiosity, mystery, and legend. Historians believe he was born in 721 CE, either in the city of Tus in Khorasan or the region of Kufa. His father, Hayyan, was a pharmacist or medicine merchant, and is often noted to have been politically connected with the Shia movement. This political association made Jabir's childhood somewhat turbulent. His father became entangled in anti-government activities and faced execution, which forced Jabir to confront harsh familial and social challenges from an early age. Amid such difficulties, he grew up under his mother's guidance. She was a learned and pious woman who nurtured his interest not only in religious studies, but also in natural sciences and medicine. From childhood, Jabir exhibited extraordinary curiosity. He was fascinated by medicinal plants, herbs, and chemical substances, and recorded his observations in small notebooks, seeds that would later grow into the foundation of his research. Upon reaching youth, he formally studied medicine and philosophy. A pivotal moment in his life was becoming a disciple of the renowned Shia Imam Jafar al-Sadiq, peace be upon him. Imam Jafar was not only a spiritual leader, but also deeply interested in natural science, philosophy, and logic. Under his guidance, Jabir acquired not only religious wisdom, but also a systematic approach to scientific inquiry. This teacher-student relationship laid the groundwork for his later experimental research. After studying medicine and chemistry, Jabir settled in Kufa, then a vibrant center of learning. The city's markets, libraries, and alchemist laboratories fascinated him. Gradually, he established his own laboratory. Legend described it as containing hundreds of sophisticated instruments, alembics, distillation apparatus, crucibles, flasks, and various chemical purification tools. Modern scientists regard him as the first to conduct laboratory-based experiments in a way that would later inspire experimental science. Another crucial chapter of his life involved political connections. During the Abbasid Caliphate, he received patronage, particularly from Caliph Harun al-Rashid's vizier, Yahya al-Barmaki. This support enabled him to manage his laboratory and pursue research. However, when the Barmakids fell from power, Jabir too faced political adversity. Many historians believe that in his later years, he lived a somewhat secluded or secretive life. There are differing opinions regarding his death. Some suggest he died in 802 CE, while others claim he lived beyond 815 CE. The sheer volume of his work is so vast that some scholars speculate that Jabir ibn Hayyan may actually represent a collective of researchers. Nevertheless, his name remains eternal in the history of science. The essence of his life can be summarized thus: childhood marked by political instability, you fill with insatiable curiosity and scientific exploration, and old age shrouded in legend. His intellectual legacy was so rich that he is still called the father of chemistry. He was not merely a student. He was an inquisitive mind capable of aone. Of the brightest chapters of Jabir ibn Hayyan's life was his pursuit of education and its multidimensional impact, absorbing any knowledge and reorganizing it in novel ways. His education began with religious and traditional studies. Alongside mastering the Quran, Hadith, and the Arabic language, he also gained deep knowledge of contemporary medicine, mathematics, astronomy, and philosophy. However, the true foundation of his scientific outlook was established through his discipleship under Imam Jafar al-Sadiq, peace be upon him. From Imam Jafar, he did not only receive spiritual instruction, but also learned a unique method to comprehend the mysteries of nature and science. The Imam taught him that knowledge is not merely obtained by reading books. It is a continuous process of delving into the depths of nature. This philosophy gave Jabir a completely new dimension in his scientific pursuits. Later, Jabir also studied the works of Greek philosophers in depth. Aristotle, Plato, and Galen's medical writings particularly influenced him. But he did not stop at learning. He began to verify and test the knowledge of the ancient Greeks through experimentation. For him, knowledge meant the combination of observation and evidence. In this way, he pioneered laboratory-based approaches in science. His early education earned him recognition as a physician. Historical records indicate that he prepared various medicines, enhancing the efficacy of herbs through chemical processes. Through his medical practice, he gained access to the upper echelons of society, eventually receiving political patronage in the Abbasid royal court. The impact of his education was not confined to himself. He created a vast intellectual network. He had numerous disciples who spread his ideas to subsequent generations. To disseminate knowledge, he authored countless works. Some sources claim 2,000, while others suggest over 3,000 books. Although there is debate over whether all were truly authored by him, the sheer volume reflects the breadth of his influence. Another aspect of his scholarly life was a sense of mystery. He often wrote in symbolic language, and complex chemical procedures were explained through metaphors or cryptic codes. As a result, European scholars later translated his books, presenting alchemy in imaginative, almost mystical terms. While this caused some confusion, it also reflected his unique approach, merging science with elements of mysticism. The direct influence of his education became evident in later centuries. When medieval universities emerged in Europe, his works were translated into Latin under the name Geber. European scientists followed his methods, moving toward laboratory-based chemistry. Even scholars like Roger Bacon, Albertus Magnus, and later Paracelsus were influenced by his theories and experiments. In summary, Jabir ibn Hayyan's education was not limited to a single discipline. He integrated religion, philosophy, medicine, mathematics, astronomy, and chemistry into a holistic worldview. This interdisciplinary learning made him a towering figure whose intellectual shadow nurtured science for centuries. Jabir's primary contribution was to the field of science we now call chemistry. Yet, his impact extended beyond chemistry to medicine, mathematics, philosophy, and even technology. He is most prominently known in chemistry. Jabir is regarded as the father of modern chemistry. In his time, chemia was a mystical discipline, blending aspects of magic. Jabir transformed this ignorance into a laboratory-based science. He believed that claims could only be verified through direct experimentation. For this reason, he invented numerous chemical processes. Historians attribute to him methods for preparing sulfuric acid, nitric acid, and hydrochloric acid, substances that later became essential in modern industry, medicine, and research. One of his most famous contributions was the distillation process, which allowed liquids to be purified. He developed an apparatus called the alembic, a precursor to modern distillation equipment. This invention had profound applications not only in chemistry, but also in medicine, perfume production, and even alcohol and solvent manufacturing. In medicine, Jabir played a crucial role. He introduced chemical processes into drug preparation, extracting active compounds from medicinal plants and transforming them into effective remedies. This gave medicine a new dimension, and he is recognized as the pioneer of medical chemistry. Another significant contribution was in metallurgy. He worked on metal purification, alloy creation, and altering the properties of metals. He even researched methods to refine gold and make other metals shine like gold. While legends link him to the quest for gold, alchemy, in reality, these experiments were aimed at understanding the properties of metals. In philosophy, Jabir was equally influential. He believed that nature is constructed in a balance and proportion. In his chemical theories, he described the four fundamental qualities, hot, cold, wet, dry, which, though reminiscent of Greek thought, he reorganized with his own scientific approach. According to him, every substance contains varying degrees of these four qualities, and understanding the precise combination reveals the nature of the substance. His writings form a vast repository. Works like Kitab al-Kimya, the Book of Chemistry, Kitab al-Sabin, the Book of 70, and Kitab al-Rajijis were later translated into Latin in Europe. These books circulated among European scholars for centuries, and his identity as Geber became immortal in European chemical history. Another remarkable aspect of his contribution was the systematic organization of knowledge. He meticulously recorded almost every experiment, process, and observation, creating a knowledge-based path for future researchers. The laboratory methodologies he developed are considered the precursors of modern laboratories. The most astonishing aspect is that Jabir ibn Hayyan was a polymath who integrated practical science, medical applications, philosophical theory, and even spiritual thought into a unified understanding of knowledge. For this reason, he was not just a scientist, but a philosopher-scientist who viewed knowledge in its entirety. Jabir ibn Hayyan was a unique medieval Islamic chemist who not only explained the processes of material transformations, but also showcased the depth of scientific thought through his writings. His works, collectively known as the Jabarian corpus, constitute a treasure trove of knowledge, identified as a collection of approximately 400 to 500 books. Although not all of these works have survived, the existing manuscripts demonstrate that Jabir was not confined merely to practical aspects of chemistry or alchemy. He also conducted theoretical analyses on the nature of substances, their properties, and the principles of their transformation. The corpus can be broadly divided into three categories. The first is practical chemistry, which details procedures for metal transformations, gold production, and various chemical reactions. Each recipe resembles a laboratory notebook, where every change in a substance was meticulously recorded through experimentation. The second category is theoretical chemistry, which goes beyond mere chemical processes, offering profound philosophical analyses of material composition, natural elements, and their classification. The third category is chemistry and medicine, which explores the application of chemical mixtures and solutions in treatments, pharmacology, and drug preparation. Among Jabir's works, particularly notable are Kitab al-Kimya, which explains fundamental chemical processes and transformations, Kitab al-Sabin, or the 70 Books, which contains extensive scientific experiments and theories, and Kitab al-Tajribat, which primarily consists of experimental notes and laboratory techniques. Each work demonstrates that Jabir was not merely a theorist, but also a practitioner of experimental scientific thought. His writings are distinctively rich in metaphors and analogies, often striving to explain complex theories in simpler terms. He integrated recipes, experiments, results, and theory into a continuous narrative, which profoundly influenced medieval European alchemy and chemistry. The Latin translations of his works later served as a foundation for modern chemistry in Europe. In short, the Jabirian corpus is not merely a collection of practical chemistry. It represents a unique combination of theoretical analysis, experimental methodology, and philosophical scientific thought, establishing Jabir as an immortal scientist in both the Islamic world and the ancient world. Jabir ibn Hayyan was not only a theoretical chemist. He was a true experimental scientist who introduced scientific methodology to the medieval Islamic world. The foundation of his research was observation, experimentation, and evidence, which earned him recognition as an early pioneer of modern scientific methods. His writings and recipes clearly show that every chemical reaction was verified not only in theory, but also through laboratory experience. A key feature of his experimental approach was systematic procedure and documentation. Jabir explained each process step by step, specifying laboratory instruments and precise quantities of substances used. For example, he experimented by combining various metals to observe transformations, recording the results in notebook form. This approach demonstrates that he practiced science through a synthesis of theory and evidence, not just practical application. Another important aspect was the development of laboratory equipment and techniques. Jabir invented various filtration, solution, heating, and measurement techniques. For every experiment, he specified the use of particular metal furnaces, glass flasks, filters, and other instruments. These tools and methods later had a significant impact on European alchemy and chemistry. Yet another unique feature of his methodology was that every experiment was linked to theoretical explanation. He not only induced material transformations, but also analyzed the underlying causes, the composition of elements, and the possible outcomes. Consequently, his writings often show experiments and theories supporting each other, an example of evidence-based scientific knowledge. In summary, Jabir ibn Hayyan's experimental methodology established the first modern framework for scientific research in the medieval Islamic world. His approach left a lasting historical example not only in chemistry, but also in the systematic structure of scientific thought. Jabir was not limited to theory and experiments. He was an innovative lab designer who advanced laboratory instruments and techniques in the medieval Islamic scientific world. His conceptual lab strategies demonstrate that he was not merely a chemist, but a practical scientific thinker. In his writings, detailed descriptions of laboratory equipment can be found. He specified the use of glass flasks, filters, condensers, heating furnaces, and metal containers. Each instrument and container was described in terms of size, weight, and appropriate conditions for transformations. These were not just practical instructions, but were linked to theoretical analysis. A notable feature of his lab methodology was safety and process control. Jabir monitored risks and temperature changes during chemical reactions to ensure each experiment was conducted accurately and safely. He created step-by-step experiment notebooks to observe the chemical reactions of various substances, which became invaluable references for future researchers. Another important aspect of his lab concept was reproducibility and verifiability of transformation processes. He designed each experiment so that other scientists could achieve the same results. This is clearly reflected in his documented recipes, instructions for mixing substances, and controlling heating processes. In short, Jabir's lab equipment and techniques were not merely technical innovations. They serve as a model for the structure of scientific methodology, safe and controlled experimentation, and reproducible processes in medieval scientific practice. His conceptual innovations later became the foundation of European alchemy and modern chemistry. Jabir ibn Hayyan was not limited to practical experiments and lab techniques. He was a philosopher-scientist who conducted profound theoretical analyses on the structure, transformation, and natural properties of matter. His writings show that he classified each substance within a specific theoretical framework, which served not only for experimentation, but also as a systematic organization of scientific thought. According to Jabir ibn Hayyan's theory, all substances are composed of fundamental elements and the combination of their qualities. He primarily classified matter based on three basic qualities, a triad: heat, cold, dryness, and moisture, which later became a precursor to the elemental theories of European chemists. Based on these qualities, he categorized metals, minerals, salts, and other compounds into various classes and determined the possibilities and processes of their transformations according to each category. Another unique aspect of his theory is the step-by-step analysis of chemical reactions. Jabir not only studied the elements of matter, but also examined the process of transformation, solubility, and the outcomes of reactions from a theoretical perspective. As a result, his writings often show that each experimental procedure was placed within a structured framework, serving as a guide for acquiring knowledge. Through classification and theoretical organization, Jabir created a cohesive scientific language that integrated both experimental and theoretical aspects. This framework became foundational not only in medieval chemistry, but also later influenced European alchemy and modern chemistry, providing a basis for the theoretical analysis of the composition and reactions of substances. In summary, Jabir ibn Hayyan's theories and classifications provided chemistry with a scientific framework, establishing an enduring model of systematic, theoretical, and experimental integration in both physics and chemical practice. Jabir's scientific activity was not confined to theory and experimentation alone. Its influence extended to practical chemistry, medicine, metallurgy, and subsequent scientific knowledge. His contributions enriched medieval Islamic society scientifically and laid the foundation for European alchemy and modern chemistry. Among his major contributions was a detailed theory on the transformation of metals and compounds, which went beyond the mere pursuit of producing gold. He analyzed the structure, qualities, and potential reactions of substances systematically. He categorized metals, salts, sulfur, and other compounds in such a way that the likely outcomes of each process and its practical applications could be determined. Jabir's laboratory techniques and equipment innovations were applied in various industries. Using metal furnaces, glass flasks, and controlled temperatures, he introduced technological advancements that later found applications in medicine, dyeing, and chemical processes. For instance, his procedures for solutions and mixtures played an important role in pharmacology for drug preparation and medical applications. Another significant contribution was the establishment of experimental methodology. Jabir documented every step of his experiments so that other researchers could reproduce the results. This approach not only organized scientific practice methodically in the medieval Islamic world, but also became the foundation for systematic experimentation in European alchemy and modern chemistry. In summary, Jabir ibn Hayyan's contributions were not merely theoretical. They were practical, technologically grounded, and socially relevant, leaving a revolutionary impact on chemistry, medicine, industry, and scientific thought. His work elevated medieval Muslim civilization to new heights of scientific excellence and provided an enduring model for future researchers and scientists. Jabir's influence was not limited to his era. He introduced the medieval Islamic world to a scientific perspective that left a profound mark on European scientific thought centuries later. His experiments, laboratory techniques, and theoretical classifications served as an immortal guide for subsequent generations of researchers and chemists. Like other scholars of the Islamic Golden Age, Jabir left behind a refined sense of scientific methodology. His works were translated into Latin in Europe, which later played a crucial role in the development of alchemy and modern chemistry. For example, European alchemists drew inspiration from his theories and experimental methods, adopting systematic analyses of metal transformations, solubility, and chemical reactions. Jabir's legacy was not limited to practical chemistry. It also influenced the systematic framework of scientific thought. He demonstrated that observation, experimentation, and theoretical analysis, when combined, produce more accurate and fruitful scientific knowledge. This principle has remained a groundbreaking foundation for both medieval and modern scientific research. In short, Jabir ibn Hayyan's influence and legacy elevated medieval Muslim civilization to new heights of scientific achievement. His writings, laboratory techniques, and theoretical analyses remain a lasting example in the history of science. He is remembered not only as a chemist, but also as an experimental thinker and scientific innovator, securing a permanent place in history. However, despite being recognized as one of the foremost chemists of the Islamic Golden Age, some controversies and critical issues surround his works and discoveries. The most significant debate concerns the authenticity of the Jabirian corpus and the true identity of its author. Historians and researchers are not fully certain whether all the texts were genuinely written by Jabir himself. Some scholars believe that many works were published under his name in the medieval period, raising questions about their authenticity. A second controversy relates to gold production and the transmutation of metals. Jabir's writings describe detailed procedures for metal transformation, which were highly valued in European alchemy. Critics, however, argue that actual metal transmutation is impossible. Thus, some view Jabir's texts as philosophical and symbolic, where experimental results were often interpreted metaphorically or allegorically. A third critical issue concerns the alignment of theory and practical processes. Jabir's works often present theory and practical instructions together. Some critics argue that this combination is not always realistic and can be confusing for a medieval reader. However, modern researchers consider this to be a subtle feature of Jabir's scientific thought, integrating experimental and theoretical knowledge seamlessly. In summary, the works of Jabir ibn Hayyan are not without controversy. Many questions surround his name regarding authorship, authenticity, and the reality of metal transmutation. Nevertheless, these debates have only added to his historical image as a complex, profound, and research-worthy scientific figure. For those who wish to study Jabir ibn Hayyan's research and writings, it is essential to have reliable references and reading lists. To understand the complex concepts of medieval Islamic chemistry and the Jabirian corpus, scholars rely on a combination of primary and secondary sources. Firstly, primary sources include direct writings of Jabir, such as the Latin translations of Kitab al-Kimya, Kitab al-Sabin, and Kitab al-Tajribat. These works clearly present his practical chemistry, laboratory techniques, and theoretical analyses. Although the original Arabic versions are not fully preserved, the Latin translations serve as valuable primary sources for researchers. Secondly, secondary sources consist of modern historical and chemical research. For instance, studies by Lawrence M. Principe and F.J.D. Johnstone explored Jabir's influence, laboratory techniques, and theoretical classifications in detail. These studies analyze the scientific value and practical applications of the Jabirian corpus. Thirdly, critical and comparative studies highlight controversies and questions regarding Jabir's legacy. These works examine the true authorship of his writings, the feasibility of metal transmutation, and his influence on both Eastern and Western scientific practices. In summary, a combined reference list is extremely helpful for studying Jabir ibn Hayyan's works. By integrating primary sources, modern research, and critical analyses, scholars gain a deeper, evidence-based understanding. Such a reference list is crucial not only for historical study, but also for comprehending early scientific processes, experimentation, and foundational concepts in chemistry. Jabir ibn Hayyan's contributions enriched the medieval Islamic world scientifically. He brought revolutionary changes to chemistry, physics, medicine, and laboratory techniques. His experimental methodology, theoretical frameworks, classifications, and lab innovations later formed the foundation of European alchemy and modern chemistry. Jabir was not merely a researcher. He was a pioneer of scientific thought, integrating philosophy, theory, and practical application into a comprehensive scientific framework. Jabir ibn Hayyan is believed to have died around 815 to 820 CE, although his exact birth and death dates are uncertain. Even after his death, his writings remain central to scholarly research in both Europe and the Muslim world. Today, Jabir ibn Hayyan is remembered not only for his influence on medieval science, but also as an enduring example for modern scientific methodology, experimental thinking, and laboratory techniques. In the history of science, He is often called a father of chemistry. His name continues to inspire researchers, students, and science enthusiasts worldwide. His works and scientific perspective remain foundational to modern chemistry and are respected globally.